Hi friends, I am Shivani from CSCD section. My roll number is 20951A058. Today's topic is openpiton, an open service hardware platform for our research. And the subject is compiler design. Introduction to the topic. Building processors for the academic research processes can be risky proportion, particularly as processors have grown in size and width. The focus on the multi-core and the many-core processors like 17, 19, 20, 21, 14, 22, 6. The number of potential points of the failures in clip fabrication has increased drastically. To combat these, the communication needs well-tested open service scalable framework the that they can rely on as baselines to work from and compare against. To reduce academic time to publication, these frameworks must provide robust software tools, software tools, mature full system software stacks, rely on industry standard industry standard language and provide through test sites. Additionally, to support the research on the board variety of the fields, these frameworks must be highly configurable, be syna- syn- synthesized to FPGA and ASIC for the prototyping prototyping purpose and provide the basis for the other to tap out manufacture their own modified academic clips. Building and supporting such an is a major is a major undertaking which has prevented such designs. Our framework OpenPython acts a change challenge and provides all of these features and more. OpenPython, the world's first open source general purpose multi-threaded many core purposes. OpenPython is the scalable and portable. The architecture supports addressing for up to 500 million cores. Supports is shared memory both within a clip and accessed across multi clips, and has been designed to easily enable high performances and 1000 plus core multiprocessors and beyond. The design is implemented in a industry standard HDL and goes out require the use of many of any new languages. OpenPython enables research from the small to large with demonstrated implementations from the slimmed down slimmed core, which is emulated on n 160 at 29 point frequency up to 25 core Python processors which targeted in 1 gigabyte frequency. Operating point was recently validated, and thoroughly characterized. The openpiton platform is shown in the figure 1 is a modern titled many core design consti- const- containing of 64-bit architecture using the using PMS. Our scalable cache, coherent, coherence, portable, and network on clip. OpenPython builds up to upon the industry hardened open source, open space T1 15.1.18.4, but stores a completely scratch built uncore cache. The picture is shown below. This is OpenPython architecture classified like this. Multiple many core clips are connected through with clipset logic and networks to build the large scalable many core systems. OpenPython AK coherence portable extents of clip. OpenPython has been designed as the platform to enable scale research. An explicit design goal of OpenPython is that it should be easily to use by the other researchers. To support these, OpenPython provides a high degree of integration and conformability, as shown in the table 1. Unlikely many other designs were the pieces and provided, but it is up to the users to compose them together. OpenPython is designed with all of the components integrated into the same easy to use build infrastructure, providing push button scalability. Researchers can easily de- deploy OpenPython source code, add in the modification, and explore their novel research ideas in the setting of fully working system. Thousands of targeted, highly covered test highly covered test cases are provided to enable researchers to innovate with a safely net that ensures of functionalities is maintained. OpenPython open sources nature as also makes it easy to realize modification and produce previous work for the compassion or reuse. This table shows the OpenPython features, component and configurable options. Cores per piece up to 65,536 cores per system, up to 5,500 million threads per core. 1 2 2 4 floating point unit present or absent present flow stream processing unit absent TLBs. These are the features of the OpenPython. Rather than simply being a platform designed by the computer architects use by the computer architecture, OpenPython enable researchers in other fields, including operating system, security, compilers, time runtime tools, systems, and and computer aided design tools to conduct research at scales. In order to enable such a wide range of applications, openpiton is com- con- configurable and extensible. The number of cores attached, input top or output size of cache, in-core parameters, and the network topology topology are all configurable for a command line option or configurable file. OpenPython is easy to extend. The presence of well-documented core and the well-documented coherence protocol and easy to interface knock make adding research features straightforward. Research extensions to the OpenPython that have already been built include several novel memory system explosions. The OpenPython platform. Platform is a tilde many-core architecture as shown in the figure 1. It is designed to scalable both intraclip and interclip used by the PMS cache coherent system. Intraclip titles are connected via 3 PMS networks on clip in a scalable 2D mesh topology. The NOC router addresses the space, supports scaling up to 256 titles in each dimension with a single OpenPython clip. For the interclip communication, the clip bridge extends the 3 NOCs of clips connecting the tile array. The tile in the upper left of to the clip logic. The clip set may be the clip may be implemented on an FPGA as the standalone clip or integrated into an open clip. Till the architecture of the till is shown in figure 2. A till consists of core and L1.5 cache and L2 cache, a floating point unit, and a CPU cache crossbar, a memory inter arrival time traffic shaper, and the 3 PMS NOC routers. Open platform OpenPython platform is shown in this figure. L2 cache slice plus directory cache connected to the PMS routers 3 MITTS traffic shaper, and these connected to the L1.5 cache, and next it is connected to the CCX attribute, and these was connected to the modified open space T1 core, and these CCX attributor was connected to the FPC PU, and the till was shown in this figure. Core. OpenPython used the open source open space T1 core with modifications. The core was chosen because of its industry hardened design, the multi-threaded capability, simplicity, and the modest silicon areas requirements equally equally important. The open space framework has an stable code base. In a default configuration for the openpiton as used in a Python, the number of threads is decreased from 4 to 2 and the stream processing unit is removed from the core to save area. The default transaction look aside buffer size is 16 entire but can be increased to 32 or 64 or decreases down to 8 entires. Additional configuration registers were added to enable extendability within the core. They, they are usable for the adding additional functionality to the core which can be configured for the software. Cache OpenPython cache is composed of three cache levels. Each still is OpenPython contains private L1 and L1.5 caches and a slice of disturbed shared L2 cache. The data path of cache is shown in figure 3. This was the figure open Python memory data path. Cache L1 cache. The L1 cache are used for the open sparse T1 designed with extensions for the configurability. They are composed of separate L1 instructions and L1 data caches, both of which are write through a four-way set associative. L1.5 data cache. The L1.5 data both the open sparse T1 CCX protocols to the PMS NOx coherence packet formats and acts as a write path layer, catching data from the write through L1 data cache. Its parameters matches the L1 data caches by data. Generally, the L1.5 issues requests on NOx 1, receives data on NOx 2, and write back a modification cache line on NO3 as shown in figure 3. L2 cache. The L2 cache is a disturbed write back cache shared by all the tiles. The default cache configuration is 64 kilobyte per tile and four-way set, but both the cache sized are associatively are configurable. The cache line size is 64 bytes large than the size of track of up to 64 shares by default. The L2 is a point of concurrence for all the cacheable memory requests. All the cacheable memory operations included atomic operations such as compare and swipe and orders, and the L2 strictly follows these orders. When the servicing request, the L2 also keeps the instructions and the data caches concurrent per the OpenSpace T1's original design. A PMS network on clip. There are three PMS NOCs in the Open piton clip. The knobs provide communication between the tiles for the cache, coherence, input and output memory traffics, and the and the inter and the intercon core and the intercore attributes. They also rotate the traffic destined for the off clip to the clip budget. To ensure the deadlocks free operations, the L1.5 cache and L2 cache and the memory controller give the different to the knock channels. In addition, all the hardware components are designed such the a commusing a high property packets in never depend on the lower configurability. The Open Python was designed to be configurable platform, making it is useful for the many applications. Table 1 shows Open Python configuration operations highlight the largest design space and it offers PYHP for the Verilog. In order to provide low effort configuration of our Verilog RTL, we make use of Python per process pre-process. The Python hypertext processors was originally designed by the Python dynamic web page generations, and it is code and code and cache capability configuration. Core and cache configurability. OpenPython and the core configurable parameters are shown in table 1. The default parameters are shown in bold. The OpenPython prefers the OpenSpark T1's availability to modify TLB sizes from 8 to 64, the power of 2, thread counts from 1 to 4, and the presence or absence of the P4, FPU and FPU. Additionally, OpenPython L1 data and the instruction caches can be doubled or halved in size. Many core scalability. PYHP also enables the creation of the scalable mesh of cores drastically reducing the core and the size and the complexity in some areas adopted from the original Spark T1 OpenSpark. The OpenPython automatically generates all the codes, instructors and writes and waits from connection them from a single template. The creation of the large two-dimensional mesh interconnects of up to 256 into 256 tiles is reduced to a single installation. The mesh can be any rectangular configuration. The dimensions do not need to power of 2. which was this was necessary features for the 5 into 5 piton processors. Validation of openpiton. When the design large scale processors, stimulation of the hardware design is must. OpenPython supports one open source and the multiple com- commercial Verilog stimulers which can be stimulate the OpenPython design at the rate 1 to 10 or hundreds of kilohertz. OpenPython inherited and then extended the OpenSpark T1 large test site which thousands of directed assemblies tests. When making the research modification to the OpenPython, the researchers can be rely on an established test suite to ensure that the modification did not introduce any additional and the Python document details how to add the new test to the validate modification and extending test strike. This figure shows the test site coverage result by the module. OpenPython design have the same features as Python processors. As we can see in the graph, the open core is 50.96% and L2 gache is 23.11% and L1.5 is 14.35% and FPU 7.74% and knock router 1 is 0.83% and the knock router 0 is 0.70%. The knock router 2 is 0.86% and CCX attribute is 0.82%. Internal research case test sites. Execution drafting exceed is an energy saving micro architectural technique for the multi-threaded processors. Exceed requires the modification to the OpenSpark T1 more and thus was not as simple as plugging in a standard module into the OpenPython system. The core micro architecture needed to understood and the implementation tightly integrated with the core. Implementation exit in OpenPython relieved several implementation details. The multi-network topology exploration. In a senior undergrad, this project investigated the impact of interclip network topologies for the large many cores processors. The student developed a configurable PMS route for this project, which is now integrated as stand OpenPython component. We can see in this picture many OpenPythons are connected to the connected to each other. Okay, friends, thank you.